Right, ladies and gentlemen, another thing that we are going to look at is the types of the intermolecular forces. Okay, remember I was talking about the intra meaning inside, and then intermolecular. Please do not be confused. There's intra meaning inside, there's intermolecular force meaning outside. So in this case, I am holding molecules together. I'm no longer talking about what? I'm not longer talking about an atom. I'm now referring to a molecule, right? One compound with the next compound and then bonding them together, okay? So these molecules are held together by the intermolecular forces, okay? So guys, in grade 10, we did touch base on the intermolecular forces, especially when you're talking about solid, liquid, and gas. You realize that we're in a solid phase, your force is very strong because particles are held at a fixed position, and as you move to liquid, the particles can be able to move with ease, meaning the forces become weaker. And then in a gas phase, you realize that the particles are all over the place. Then that tells you that the forces are at their weakest. Now, the forces that we were talking about then in grade 10 are the intermolecular forces. Okay. Now, as you move to grade 11, you then realize that there's types of intermolecular forces that we have. Okay. Now, the first one that I'm going to talk about is called the ion dipole force. The ion dipole force. Now, the name itself, ion dipole, says that there must be a presence of an ion, and then there must be a presence of a permanent dipole. Now, how will these two now exchange the force? How will these two now exchange these ions? Now, you need to realize when I talk about a dipole, I am talking about a substance that has one side being slightly positive and the other side being slightly negative. That is a permanent dipole that I'm talking about. An ion can be positive or negative. When I'm talking about an ion, guys, I'm talking about a cation ion, or it can also be an anion, okay? So if you are having an interaction between these two, then we realize that the interaction then creates a type of force which is called the ion dipole force. Remember, dipole, it's a permanent polar molecule, meaning it has a positive side and a negative side. So that is how we come about to have a what? An ion dipole force. The next type of force that we are going to talk about is the dipole force. Okay? A dipole force, from the name itself, it tells you that we need to have two permanent dipoles, right? Two permanent dipoles, they interact in such a way that a positive will go to a negative goes to a positive. Okay, now that type of interaction in terms of the charges that they have, then it makes it a dipole force. Now, in this case, it can be in a sense that, for instance, if we have sodium chloride and water is a permanent dipole, sodium is a permanent dipole. The interaction between the two then causes what we call a dipole force. The next type of a force that we have is called a dipole-induced dipole. Dipole-induced dipole. Now, you need to understand that now I've introduced another word, induced. Okay, the word induced in this context means to create. Okay, it's a dipole. That means I have a permanent dipole that is going to create another dipole. Guys, how do you create another dipole? You create another dipole from a non-polar. That means this other substance must be a non-polar. Okay, if it's a non-polar, then we can temporarily create a what? A polar molecule. How does that happen? Say I am surrounded by negatives, right? If I take a permanent dipole, which on the negative side of the permanent dipole, and I try to bring negative and negative together, what's going to happen is we are going to experience a force of repulsion, because the negatives, they do not attract, guys. There's a force of repulsion. So as soon as there's a force of repulsion, I'm realizing that the negatives on this particular structure will then shift to one side, because they are running away from the negative of what? Of a dipole. Okay? So temporarily, when I introduce a situation like that, I am actually inducing, I am creating a temporary dipole. Okay, so the interaction between a permanent dipole and a nonpolar then induces a dipole. So that's what happens in that particular type of a force. Now, another type of a force that we get is called the induced dipole. Induced dipole. Now, induced dipole means I have two non-polar molecules. Originally, that's what I have, two non-polar molecules. The interaction between the two, I want you to picture this, guys. Say this particular element has negatives. This one also has negatives, right? If you are trying to bring the two together, one thing that you're going to observe first is the force of repulsion. The negatives of this particular molecule will shift to one side. The negative of this particular molecule will shift to one side. So automatically it leaves what? It leaves this side with a slightly positive, simply because the cloud of electrons is on the other side of the molecule. The same thing happens to this. The cloud is on the other side of the what? Of the molecule. So temporarily, I have created a situation where this becomes a temporary dipole, and this element also, the substance becomes a temporary dipole. That's what we mean by induced dipole.